to Tim Benning, a professor with the School of Physics. Tim is well known for his memorable lecture demonstrations in first-year mechanics, but he is also a leading researcher in astroseismology. This field involves using the oscillation frequencies of a star to measure its internal properties, such as age and composition. What is your hot beverage of choice?
So I love to have a coffee every day at Ralph's, but then after that I have tea. This is my favourite teacup. There's a story behind this if you want to hear it.
Yes, please.
So I used to teach second year optics and diffraction, and there's something called a blazed diffraction grating. And a blaze is where the surface is grooved, a bit like a Christmas tree in that kind of shape. And the reason it's called blazed is it's like blazing a trail. If you go through a forest, you cut a notch in the tree. And I was telling the students about this, blazed diffraction gratings, and they were giggling, and I couldn't understand why. And then at the end of the course, they gave me this as a gift, because it turns out that the word blazed means marijuana, which I didn't know until I did that course. So that's why this is my favourite cup.
Where are you from and how did you end up at the University of Sydney?
So I grew up in Sydney and I went to Sydney Uni as a student. I did a science degree here, back when you could just do a BSc, there wasn't even an advanced degree. And then I stayed on to do a PhD in astrophysics. And then I went overseas for a few years. I went to Germany and did a postdoc in Munich at the European Southern Observatory. And then I came back here as a lecturer and I was lucky enough to get a lecturing position. And I've been back here ever since.
And which high school did you go to?
So I went to a high school called Beacon Hill, which actually doesn't exist anymore. It was demolished to make way for houses a few years ago. So I grew up on the northern beaches and went to a government school. And I wasn't really sure which uni to go to. And my science teacher said, yeah, if you like astronomy, then probably Sydney Uni is a good place to go. I hadn't set foot on the campus until my first day of university, in fact.
What made you want to pursue a career in physics?
I grew up watching TV, Carl Sagan, things like that, so I was always interested in astronomy, and I liked physics at school. I had a really good physics teacher. In fact, he was a biologist by training, but he retrained so that he could teach physics. And I just loved physics, and when I came to uni, I found physics engaging. I found the physics lecturers to be really good. I have to say the chemistry lecturers back then weren't so good. I'm sure they're much better now. And as I went through uni, I just enjoyed physics and maths, so that's why I ended up majoring in.
Would you like to tell us more about your specific research field in astroseismology?
Yeah, so astroseismology is the study of star quakes. Basically, a star is a huge ball of gas, big sphere held together by gravity, and it will oscillate in standing waves. So physics students know what standing waves are. They're essentially sound waves that vibrate. And so a star will do that in 3 dimensions. And by measuring the frequencies of those waves, you can tell a lot about what's going on inside the star. So this is a nice example of a standing wave demonstration I like to do in class. So you can hear there the different notes that are playing inside this tube. They're called overtone modes, and each one of them has a different frequency and a different pattern inside here. Now if you imagine this was a 3-dimensional object like a star, you could use the frequencies of those notes to measure essentially the speed of sound through the middle. And the speed of sound depends on the temperature of the gas, but it also depends on other things. For example, in the middle of a star, hydrogen is always burning into helium, and the speed of sound is different in those two things. And so as time goes by, the oscillation frequencies of a star change slowly with time.
If there was another universe where you weren't a physicist, what would you be?
That's a hard question, but I like to read a lot about popular science, and I'm fascinated by molecular biology, DNA and evolution and genetics and that sort of thing. So I suppose that's probably the field that I'd like to go into if I had another life. But, you know, I'm happy with what I do, so...
Do you have any hobbies or hidden talent?
Well, I used to play a lot of frisbee, ultimate frisbee, long ago. In fact, when I was a student here, it was just starting up in Australia. So my friends and I were among the first to play in Australia. And in fact, I was actually able to play for Australia in the ultimate frisbee team, but this is a long time ago. So these days, not so much. I love to read, I love music. I went to a concert in the Opera House the other day for the first time in more than a year, which was fantastic.
What is your favourite part of the university campus?
I love the physics building. I know that sounds pretty biased, but I've been to a lot of universities, and the reason I like the building is it's long, and so you can see people from the far end. In fact, I was told once it's 1/10 of a mile long from one end to the other. My office is right down one end. I can come out and look down the corridor and see people. Whereas I've been to other places where, for example, at Melbourne Uni, physics is in a tower block. Yeah, so you go in the morning, you get in the lift, you go up to your floor, and you maybe don't see people. But I love the campus. I love walking around the campus. It's a beautiful place.
When you get the chance to switch off, what do you like spending time on?
I like to read. I normally don't read much fiction because I find with fiction I need to pick it up and keep reading it. Whereas with non-fiction I can put it down and come back to it. So, especially during COVID, I've done a lot more reading than I have before. I did read the entire Game of Thrones last year, though. It took me a while to get through all of them, which I enjoyed. But mostly, I like to read maybe a bit of history, a bit of popular science. I'm reading a book at the moment about a Soviet physicist who grew up during the Cold War, and it's fascinating to read all of the politics about how things were and the machinations of the Soviet Union during the arms race.
Is that your favourite book, or do you have one that's quite close to your heart?
Probably my favourite science writer would be Richard Dawkins. His books about evolution and the selfish gene and so on. He just writes so well. I like to write, and it takes me a long time to do, so I can understand how much effort he put into crafting every single sentence to come out perfectly.
If you could choose a superpower, what would it be and why?
So I would like, I don't know if it's technically a superpower, not so much time travel as long life, in the sense that I would love to be able to, after I die, wake up in 100 years, have a look around and see what's changed, and then do that again in another 100 years. I read a science fiction book once where there was a drug that allowed you to do that. You essentially had the same lifespan as before, but you could divide it up into segments and sleep between them. I'd love to see what the world turns out like. What will our technology be like in 100, 200, 300, 1,000 years?
Can you tell us a little bit about your lecturing philosophy?
Well, I love to lecture interactively, and of course COVID has spoiled that a lot, but I love to interact with the students and have it more like a discussion, a conversation. I love to use demonstrations. We have a great lecture demonstration here in physics, and use each demonstration to ask questions and pose questions. So my philosophy is helping students understand difficult concepts. Physics is tricky. It's not easy. And it takes a while, and it's absolutely true to say you never know something until you have to teach it yourself. I've learned so much from teaching physics, much more than I ever did as a student. Yeah, it's not until you try to explain something you realise, oh yeah, I never really understood that.
Finally, with your experience in physics, what piece of advice would you give going into the university for the first time?
I would say keep your options open. So unless you really know exactly what you want to specialise in, just take a sample from across the board. These new OLEs are really good for that. I know they're a bit of a pain in the sense that they inject themselves inside the syllabus, but they give students a chance to sample from different areas. And most people don't really know what they're interested in until they try it. You come to university with an idea, but you really don't know. So try lots of things. Try everything out is what I would advise.
Thanks, Tim. We hope you have a great semester.
Thank you very much.